Alright, so 2025, paper 1. Alright, so contrapositive. If Jomo is not rich, he's not a minor. F of x plus 2. Logically equivalent. So this is the repeat, not P and not Q. G inverse of f of 3 is a half. This can be simplified to 7 root 5. Using summation, this will be the r plus 1 and 3 to the r. Yeah, because it's alternating good. Which of the following factors of this? This is a repeat question. I know 1 and 2 are factors and not, no. I know 2 and 3 are factors. I'm not so sure about 1. If I remember correctly, the remainder we got when the function was divided by x minus 1 was, I want to say, minus 4. So let me check it back and see, right? X plus 1, x will be minus 1. So I'll get 4, take away 8. Minus 1 squared is going to be 1. So I'll go have the minus 2. Then I'll go have plus 6 minus 4 equals minus 4. So part 1 is not a solution, so it has to be 2 and 3 only. Alright, so this here, the modulus function is always positive. This is bijective. The range of this, so if the range is that the domain, right, so the domain would have been this here. This would be log 16, it was 16, right? 2 to the 4 to the, and multiply by 2, yes, it was 16. 2 is the only one that will give us non-negative. The third root is 1.5, which is 3 over 2. A half ln of x minus k. So real repeats coming in 2025. So in this one here, it was x is less than a over 3, and it was a on that side and a over 3 on this side. Let me go back and see. This is a common repeat question. Let me check back 2019. I know it's one on it. I know for sure it here. Yeah. Less than a over 3. Let me make sure it's modulus of 2x minus a is greater than mod x. 2x minus a is greater than mod x. Yep. A. The value of theta that satisfies this is pi on 3. The angle between these vectors, check it back and see. 2 minus 4 plus 2, pi on 2. Minimum value is minus root 89. Alright, so number 19. Let's go through the proof for this one. Sine squared x minus cos squared x. It have 3 identities for that. I'm just going to put 1 minus 2 sine squared x and see where we go. Tan squared x minus 1 is going to be sine squared x over cos squared x minus 1, which is sine squared minus cos squared over cos squared. We can leave it up as that, man. Sine squared x minus cos squared x. So this is equal to sine squared x minus cos squared x multiplied by cos squared x over sine squared x minus cos squared x, bam bam, and we get cos squared x for number 19. Number 20 is going to be B. 21, this one was a tangent, so it touches the curve at the point 24. So again, you could watch the answers, and I watch the question and know what the answer is. You could kind of get the answer from the question, from the answers. All right, for this one here, we did do this question just now. Let me do it over. X1, Y1, X2, Y2. Y2 minus Y1 over X2 minus X1. 4/5 is going to be my gradient of the radius. The gradient of the tangent could be, 4 over minus 5. gradient of the tangent is 5 over 4. So we're going to get y minus y1 is equal to 5 over 4 into x minus 5. Y is equal to 5 over 4x plus 25 on 4 plus 4. Multiply everything by 4. 5y plus 25 plus 16. We get 41 day. 4y is 5x, sorry. So if 5x is positive and I move the 4y across, I get 5x minus 4y plus 41. So the answer is D. A curve is defined by the parametric equations that and that, the Cartesian. So from this, t is equal to y minus 2. So x is equal to 3 plus 2 into y minus 2. We have the x first, then we have the y. So 2y bringing across becomes minus 2y. And this becomes 3 take away 4 is minus 1. X minus 2y is minus 1. D is the answer. This is a repeat number 24. We get negative tan t. This one here would be, is a repeat, but just double checking. For the x coefficient, I'm going to get minus 2 plus 8, which is 6. For the y coefficient, I'll get minus 6 plus 8, which is 2. And for the constant, we get minus 15. Divide everything by 2. 3x plus y, minus 30, minus 15. 3x plus y minus 15, the answer is C. The length of the vector PQ is, so you see how they change, and notice that they change the position of 5 root 2. So I don't know if the size of this vector is going to be 50, root 50, sorry. So let me get the vector PQ. So PQ is negative OP, which is negative 2, 1, negative 8, plus minus 1, plus 4, plus 4. So we will still get back the 50. 9, 25, and 16, we getting back the 50. So it's going to be 5 root 2. A unit vector parallel, so we go check back and see which one is going to be unit vector. The only one that's a unit vector is D. 1/5. When I square that, again 1/5. 1 over root 5. When I square that, I get 1/5. 2 over root 5. When I square that, I get 4/5. Add them together, I'm going to get 1. Alright, so the angle between the vectors. Alright, so this is a repeat question. It's going to be root 19 over root 42 root 46, cos inverse of that. So minus 19 divided by root 42 multiplied by root 46. Okay, that's not looking right, so calculator playing up. 42 by 46 is 1932. So it's minus 19 divided by the root of 1932. And it's going to be cos inverse of this to give me 115.61. Now, I want to check something here, right? Cosine of the answer is that by minus 1. And cos inverse of that is this. So we got cosine to be negative is in quadrant 1 and. So 180 take away this is 115.61. Good. So confirming the answer is indeed 115.61. Alright, so this one here is another repeat. So the answer for this is D, because this vector here is the vector AB but in the reverse, so it's the vector BA. A curve C is given by the parametric equation x and t. The equation is I know it was minus 56. I think it was A. So let me confirm it is indeed A, right? So x minus 2 over 3. That's going to be t. So it's t squared plus x minus 2 over 3. X squared minus 4x plus 4 over 9. Plus x minus 2 over 3 minus 6. So multiply everything by 9. So when I multiply by 9, this is going to be 3x minus 6. So minus 4x plus 3x is going to give me minus x. So A is the answer. The differential of this, we're going to have x cos x plus 3 sin x. So the answer is C. Which of the following real functions has a point of discontinuity? It's going to be D because I can solve the denominator. X will be minus 1 on the denominator. 33 is minus 20. 34. Let's double check and see what the differential is going to be, right? I know it's going to be 108 sine 6x, but I don't know if it's plus or minus. When I differentiate sine once, I'm going to get cosine, so the minus persists. When I differentiate cosine, I'm going to get negative sine, so the minus changes to a plus. D is the answer. 35, L'Hopital looking like the play here. 2x, 3 2s are 6. Plus or minus a quarter. This one was 48 root y. 4 2s are 8. And then 8 3s are 24 by 2 is 48. Yep. This one, this was minus 1. Let me check it back. I think it was, yeah, it was indeed minus 1, but let me check it back, right? Y is equal to 2x plus 1 to the power a half. Differentiate to get the first derivative, a half multiplied by 2. 2x plus 1 to the minus a half. Differentiate again. This becomes 1. I'll get minus a half into 2 into 2x plus 1 to the minus 3 over 2. This becomes minus 1. So the only one that has minus 1 on the numerator is D. Y prime is cos x minus sine 2x. I mean, I know it's a repeat, but it wouldn't hurt us to go and rework it out. When I integrate cosine, I get sine. When I integrate sine, I get negative cosine. So that changes to cosine 2x. And I had to divide by the angle, the differential of the angle, which is 2. So it's positives all around with a half on the cosine 2x. Positive all around with a half on the cosine 2x. Alright, so similar scenario here. This is a repeat question. Nothing will hurt if we do it over. So we're going to get cosine of 3x squared minus 1 to the power of 3. 3 into cosine of 3x squared minus 1 squared multiplied by the differential of the angle, which is going to be 6x minus 6x sine of 3x squared minus 1 multiplying the 6 and the 8, the 3 minus 18x are going to get cosine squared of the angle and are going to get sine of the angle. So minus 18 cosine squared D. So again, look at number 41. They change the way option D looks, right? It's still correct, but they just change the way it looks. The gradient of the normal to the curve, 6x minus 2, 6 into 1 minus 2, which is 4. That's the gradient of the tangent. The gradient of the normal is minus a quarter. This would have been 8 pi for it to be the answer. The volume of the solid generated when the region enclosed by this, the y-axis. So we have the integral between 4 and 0 of pi y dy, because I x squared, yep. So pi y squared on 2, which is going to be 4 squared on 2, which is 16 on 2, which is 8 pi. So I'm doing a lot of working mentally here, right? Okay, looking like newish question territory. I want to say is minus 21. V, no, there's a repeat question. By du dx minus u by dv dx. And I'm going to work out v squared. 3 minus 4x plus 4x minus 24 minus 21. And lastly, this will be 2/5. And that is it for 2025. So again, if it is you see a repeat question and you don't know the working for it, watch the videos from the first one, 2018, come up the road. All right.